Euclid's Elements, Book 3, Proposition 18. If a straight line touch a circle and from the center of the circle a line be joined to the point of contact, that straight line so joined will be perpendicular to the touching line, also known as the tangent. So if we have a circle, let's have circle A, B, C, and let's have another straight line touching this circle at, say, the point of contact C. So let's have line DE touching the circle. If we take the center of the circle, and from the center, we draw a line to the point of contact, then that straight line will be perpendicular to this cutting line, or this, what's known as the tangent line. So I say that FC is perpendicular to DE. And this is a proof by contradiction, so we're going to assume for the moment that that's not true. So if FC is not perpendicular to DE, then there is some other line that is perpendicular, because from any point we can draw a line perpendicular to a given line. So let's draw, if this isn't perpendicular, let's draw the line that is perpendicular. So let it be FG. So the first thing we're going to do is we're going to draw FG perpendicular to DE. And we're going to see how that leads to a contradiction. So basically we're saying if this isn't perpendicular, some other line is. And so let's draw FG as that line. So if FG is perpendicular, then it's at a right angle. And so in a triangle, if we have one angle that's a right angle, then no other angle can be a right angle, it has to be less. So let's look at angle FCG, this angle here. Angle FCG, if this is a right angle, then this must be less than a right angle, because any two angles taken together have to be less than two right angles. And since this is already one, this has to be less than a full right angle. That's Book 1, Proposition 17. Well, if this is a greater angle than this in this triangle, we know that the greater angle is subtended by the greater side. So we know that side FC has to be greater than the side FG. And that is Proposition 19 of Book 1. The greater angle is subtended by the greater side. But we know that FC is equal to FB because they're both radii of the same circle. Therefore, we can just substitute FB in for FC. And that means that FB is greater than FG. FB is greater than FG. But wait a minute, FB is lesser, and we're saying that the lesser is greater than the greater? That is, of course, impossible. So we have to reject this. And therefore we have to reject the assumption that gave rise to this, and that is that some other line other than FC is perpendicular. So FG can't be perpendicular to DE. And likewise, we can show that any other line that we pick, if we pick a line here, that the same absurdity occurs. If we pick another line here, the same absurdity occurs. It's going to occur anywhere we draw FG except at FC. Therefore, FC is perpendicular to DE, our tangent line. And that's, of course, what we're trying to prove. So since we've done that, we conclude with QED.